Hi everyone, this is Ale, saying hello from Singapore. I'm a mobile engineer working in financial industry, and I'm truly excited to have this sharing in Android Mobile. So today I'm going to talk about Kotlin Symbol Processing tricks. To help our sharing more inclusive, let me have a quick introduction for KSP. So KSP is a meta programming tool. It leverages the Kotlin compiler plugin capability to export Kotlin simple information. Basically, the Kotlin or Java source code will be transformed to a simple tree like this one. And later, all simple information will be passing to the KSP processor. So there's a provider, then the processor. So based on simple information, we can generate some new files. And those new files will be processed again until there's no new files anymore. So you may wonder, what are those new files doing? New files generated by KSP are usually templates, helper classes, and so on. Yeah, so for example, the room library, which encapsulates the SQLite, provides some annotations like this. So they work on interface and function to describe some SQL commands. Here we pay attention to the first function, the get alphabet words here. So soon after comparing, it will generate this one. Here I did not bring the entire class due to the screen size, sorry. So I only pick up the get alphabetics words function here. But you can see with the help of the processor, it consumes the annotations parameters, the function name, the return type, to build up a full functional SQL query, including many safe actions, as you can see, some try catch, some finalize functions. So in this case, for every DAO file, we don't need to do those things manually and repeatedly. Based on KSP, we can just generate them in compile time. Okay, last point is the KSP versus KPT. Yeah, so everyone will talk about it. The KPT is created by JetBrains officially a few years ago. However, it brings however, it bridges to the Java APT that requires one more step to generate Java stub from Kotlin source code. So the performance is actually not good enough. Well, for the new library, the KSP, it leverages new Kotlin compiler plugin API, consumes the Kotlin symbol directly. So from the comparison of room library benchmark, KSP is 2 times fast than KPT. In the meantime, KPT has been moved to the maintenance mode. Also, third-party libraries are recommended to migrate to KSP as well. So, yeah, that's about the background of the KSP. And okay, yeah, coming to our main dish today. Our topic is to introduce some advanced skills of KSP. We will go through the topic by 2 dimensions, deep and broad. There are 5 tricks totally that we are going to discuss. So let's get started. Okay, for the first section, I would like to introduce the file arguments trick. From API document of the KSP, we can easily find its Gradle DSL to pass key value arguments like the code shows here. But if we want to pass the file path as the argument, here we need to retrieve it from the option. Then we need to read the content from the file. But be careful in this use case, yeah, because it may cause some caching problems. The first thing we need to know is, so far, KSP has no idea on how to distinguish whether the value is a file or not. From what KSP could understand, they are all strings. Yeah, so only our developers know how to deal with those files. So as for incremental build, we expect that once the input file changed, I mean the file content changed, not only the file name, KSP should rerun the processor with new file content. But unfortunately, if we just pass the regular key value argument, like what we showed before, the KSP Gradle task doesn't take it as a file input. Even though the file content changed, it will still skip this task. So yeah, now the solution is quite straightforward. If the content of the target file changed, the KSP task needs to be aware of that. This is a very classic Gradle problem. We can solve it within the Gradle scope. Here I refer to the Gradle runtime API. Just pay attention to the highlight code here. We call the input stop file to add one additional file for KSP task. In this way, KSP task can get notified once the file content changed. And then we can run our processor logic, read the file content and do what we want. So the solution looks quite neat, just 3 more lines, then we solve the problem. But however, it has an extra dependency, which is the class name of the KSP task here. It is not part of the KSP API, so if the class name changed, we will know from their document in the future. And this may break our flow if the new API, if the new KSP library updates this KSP task class name. So luckily, starting from KSP 1.0.5, there's a new API that solves our problem as well. It's called the CommandLineArgumentProvider. We need to create a class that implements this CommandLineArgumentProvider interface. There are 2 key places of this implementation. First one, pay attention to the constructor parameter. As you can see, the local property, which is a file. The interesting thing here is we can declare extra Gradle task property attached on it. So for example, you can add something like input file, page sensitive, or any other task-related annotations. Those annotations can let Gradle understand that a task should get notified when this file changed, since this the task input. So the second one, we need to override the asArgument method. In this method, we assemble the key and the value in one string to simulate the same operation as the regular KSP arg API. And eventually, we can call another overloaded the KSP arg API here. But it accepts the CommandLineArgumentProvider, and then we put the file instance into this provider. So this solution comes from a Gradle staff by this pull request. You can check more from the link. But I know you may still wonder, how does it work? Because this is not a Gradle task. Why those annotations can use here? And how does it link to the KSP task? So the secret is hidden inside the KSP task. All CommandLineArgumentProviders will eventually pass to this place. And here you can see the nested annotation is attached to CommandLineArgumentProvider property. That means Gradle will extract our CommandLineArgumentProvider, identify and collect our nested input files. So this will link to your properties declaration in the constructor before. This one. And the local properties will be linked to here. That means whenever those files content change, Gradle will mark the cache as expired and retrigger the KSP task. Okay, perfect. The CommandLineArgumentProvider is actually an API coming from Gradle. And this is not the first time we see it used in Annotation Processor. So if you visit the under-build document on AGP and the room library section, you will find this useful tip. You can check more from the link here. So yeah, that's about our first trick. The next, second one is also associated to KSP arguments. It's called variant-aware arguments. So the scenario is quite straightforward. Sometimes we want a feature only enabled in debug mode. For example, we want to add some logs to our generated file at debug stage. We may write the code just like this one. It checks the Gradle command and decides if we need to enable a log. However, the above snippet does not work for Gradle symbol command. In this command, it does not include any variant information. It basically builds all variants together. So its debug property here is not reliable anymore because the value will always be false for all variants. Then what will be the solution? Actually, we can learn something from Gradle plugin. For Android configuration, we can set different debuggable value for each variant. So similar to this one, here we can separate arguments to variant-specific ones. So as you can see, I added some suffix to the original log enable key, and now they become log enable.debug, pre-release, .release. So we can just config and pass name respectively. Okay, yeah, but we only solved 50% of the problem so far. After those arguments settle down, how could we extract them in processors? Or in another word, what is the current variant that our processor is running within? Unlikely, I did not find a public API or other neat solutions. So this is a workaround that I used in my project. It leverages reflection to extract resources directory property from code generator implementation class. KSP knows what is the current variant and generates new files to corresponding directory. That's what we already know. And yeah, that's why we can rely on that and retrieve the variant name from it. So later you can create an instance of the variant awareness class and reuse anywhere you like. So for example, here you can use it along with the log enable property key to extract corresponding config. Yeah, so that's about our second trick. The third one, I would like to introduce something new, the multi-processors workflow. The scenario is when you run a processor, they export some source code or some reports for external users. They may not be satisfied with the data structure you provided, and they may file a feature request for you, to provide some custom options for me. However, we all know, even though we've provided some options already, we cannot make everyone happy still. So the best way is to separate focus. From our end, we offer the raw data only. For external users, they decide the generation format by themselves. So to do so, external users should have their own processors so that they can receive data passing from our processor. So let's plan to work on the multi-processors. Okay, based on the plan, we can design the flow like this. From our processor, except the default output file, we add one additional generated files called aggregated meta. So later we feed it to the third-party custom processor and they can do whatever they want. But you may still wonder, how does the third-party processor receive our data? So the trick is we put an annotation into the aggregated meta file, and then the third-party processor use the get symbols with annotation to locate our file. Because of the multi-round processing feature of KSP, so the third-party processor will receive our data in the second or following rounds. However, we still have a question: how to design our raw data format? I mean, the elements portion here, below the extent here. But before going through that, I need to give some limitations of the KSP capability. For KSP or KAPT, they are compiler plugins. They work on analysis stage. So at this moment, actually, user cannot extract expressions info. Only symbol and declarations are available. So, for example, there's a property called ABC. You also know the type of it is a map. Okay. But for the content, we actually don't know what is the content at this stage. So that's a big problem for our design, because the content is only available in runtime, and we were expecting to deliver raw data to our external users during the comparing stage. So how to deal with that? Can think about it. Okay, the solution is coming from an exception. The annotation parameters are the only resolvable data at this moment. That means if we can put our data as annotation parameters, then third-party processors can get it in runtime. So let's combine these two ideas together and check the example. So here we serialize our raw data, transform them to JSON string, and use it as the annotation parameter. When third-party processor locates our source code here by the extend annotation, they can also extract raw data from the same places. And in this way, we pass the data in compile time successfully. So later, external processors, they can generate whatever they want. But lastly, for temporary files like this one, now they are only used in compile time. So do we need to remove them from our final APK? The answer should be yes, right? Actually, once the user enabled a verification tool like ProGuard or RA, they will be automatically removed. Because there is no reference to those files. So good news, we don't need to concern about it. And that's about it. This trick is a bit complex than first two. But don't worry, we will reuse it later in our next trick, but in different scenario. So hopefully the repeating can help everyone to remember it. Okay, let's move to the next one. So we all know nowadays many applications have multi-modules, and it's quite common to run some aggregating tasks from multi-modules based on KSP. Let's say we have some services that would like to be registered in application module, like this one. But those services are coming from other modules, and they have been attached with the annotation, the export service here. So we want to aggregate the name and register in our main application module. But how to visit those dependencies code from current module? That is the question. Okay, but before going through the solution, let's take a look on some special methods from KSP Resolver interface. There are 5 methods I would like to introduce here in order to get our feature done. The first one is get case name from string. It's basically to transform elements, the elements canonical name to case name object. Sorry. And the case name is a prerequisite for following three methods. So as you can see, their parameters are actually case name here. So the get class declarations by name, function declarations by name, property declarations by name, they are all associated to the first methods. And the last one, which is highlighted, the get declarations from package name, is a bit different. So you can pass the package name in, it returns a sequence of case declaration. Case declaration may contain classes, functions, and properties. Okay, so here the interesting thing is these APIs, their scanning scope is not only the current module, but also all dependencies. That means if you want, you can get everything you need from the main Android application module by using these APIs. But be noticed again, you need to have the exact case name or package name in order to fetch the case declaration. And this sounds a bit cumbersome, yeah, because it's hard to get those case names from the module in advance. And it's also a bit difficult to tell our user that we need a dedicated package name for their services. So those APIs, they look valuable, but we are still confused about how to use them in production. Yeah, but fortunately, yeah, I found out a solution, of course, yeah, from the KSP issue list. You can go and check out the link later, okay? So actually, the last API, which is highlighted here, is proposed by this issue owner. And this is the core API that can help us to solve the problem. Okay, let's go through the solution. We can go from left to right. The blue portion here, they are source code coming from the different modules. Because they are written by external users, so the package name can be various. The key point here is we need to separate one processor into two different processors. As you can see, there are two red portions. So the first portion here is called the meta processor, and it consumes services from different modules. The content of metadata, then this processor will generate the metadata file for each module, and the content of every metadata file services information of current module. As you can see, module A, module B. So these two will generate this one, and these two will generate this one. We can aggregate the name by get symbols with annotation or get new files. Okay, yeah, but since these two files are temporary files and generated by us, we can define a dedicated package name for name. Well, I think you got it already, right? So with the dedicated package name, we can create another processor to aggregate all the services information by get declarations from package. So finally, yeah, we got all elements from different modules, so we can generate the final one, the final aggregation.kt file. Yeah, but you may still wonder, does two processors slow down our compiling time? So to be noticed, this aggregate processor is only placed in the Android application module only, and usually it runs only one time per building and calls one API only. So I think that does not impact our performance at all from my testing. With this solution, we don't require user to put files in dedicated package name because we add one more step to generate some files in the dedicated package name already. So also this extra step. It is not consuming, so it's perfect to balance the user experience and performance here. Okay, let's have a quick review on the metadata file and the final aggregation file. For the metadata, actually, we just reuse the same trick as what we mentioned before in multi-processor workflow. We use the same JSON format to describe the module's metadata. The only difference is we created another annotation here, as you can see, at meta. For this specific use case, our aggregation processor can collect all metadata in compile time. For the final aggregation, there are just some properties, so transformed from the metadata JSON string. And yeah, it's about the aggregating data from dependencies. Okay, the last trick is beyond annotation processor. So we know KSP can transfer source code to a simple tree like this one. To be noticed, this is a full description of a Kotlin source or Java source, yeah, including all symbols. This actually we can do something more than just annotation processing. A quick review of what people usually do in KSP here. So look at the highlighted code. The resolver.get symbols with annotation, blah, 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 is a common API that we used in KSP processor. Yeah, but if we dive into the implementation of this function, it contains two steps. First, it fetches new files of this round. Second, it creates a visitor to filter elements by specific annotation. Okay, so the tricky thing is we can just call this get new files API directly. It's public to everyone. So we can pass our custom visitor to it. That means we can troubleshoot all elements from root, filter what we want. It doesn't need to be an annotation. It could be like class type, property type, or any other things. So for example, in this visitor, we checked if the current class is assignable from some target class types. Those target class types can be passed from external arguments, as you know, the Gradle scripts. So based on this capability, we can create something different. Remember this sample, right? When we talk about aggregating elements from dependencies. Now we can just remove the annotation, replace it with an interface or abstract class, yeah, anything you like, and we can still locate name by custom filters. It's what we mentioned before. Use this trick. The performance of the custom filter depends on how deep and how many times you traverse a ways. So from my experience, if you just check the class type or property type like this one, you can get the excellent performance, just like the built-in annotation filter, the one get symbols with annotation. Okay, yeah, that's almost everything for today. And in the end, I would like to share this open source repository that I mentioned in the beginning. That is created by me, and you can find all tricks we mentioned today from here. It's called concact. The core function of this library is to aggregate Kotlin symbols based on KSP for multi-module development in compile time. I also discussed some tricks of this concact library with Zhang, who is the author of KSP from Google. And he said some of them are not typical ways to do annotation processing. Yeah, but it's not an abuse. So yeah, feel free to try it out. And thank you everyone. And special thanks for Android Mobile team, Shalom and Anna. Yeah, And thanks again. Yeah, I think we can proceed to Q&A, Anna.
Well, Zhang, and this was really awesome talk, and it was really brilliant information. I have several questions. Could you tell me what is the most prospectful area to use KSP on modern projects? What do you think so?
You know, KSP can run in isolating mode and aggregating mode. So for aggregating mode, definitely you will encounter this multi-module problem in the future sometimes. Yeah, so that is the better case to use it. Yeah, and in our case, for example, by the time I use the Kotlin dependency injection library, you know, that I need to register all the Kotlin bins to one places. I mean, maybe it's the Android application. Yeah. So in this case, yeah, we need to aggregate many things and put them all together, register them, yeah, in these places. So this is I think the best case we can consider about it.
Okay, and here we go with Q&A section. The first question, in Gradle, does KSP happen as a separate task? If yes, can we add a dependency task for KSP, like generating annotated code from JSON file, which in turn gets transformed by KSP?
Okay, you can do that. Yeah, actually, you can find my historical in that concat library. Yeah, I did in that way as well. Yeah, but now I changed it a bit. Yeah, so technically this is possible to do. Yeah, but for the scenario of this question, the audience, they are generating annotated code from a JSON file, which in turn gets transformed by KSP. I think this is not the typical way to leverage the KSP capability. You can just register another Gradle task and attach it to the Java or Kotlin compile task. And actually, there is a new API you can extract or you can find it out from the AGP 7.3.0, yeah, from the Android Recite GitHub repository. Yeah, and there is another way, yeah, you can attach some new Java codes, some new Kotlin codes to the compiler. Yeah, so you don't need to use the KSP in this case, okay.
Thank you. Next one. As a person who has never written a compiler plugin, what is a good way to get started with KSP?
Yeah, so that's why we have KSP. Yeah, because a Kotlin compiler plugin is a bit heavy. Yeah, than our daily development. Yeah, I think Anna is the expert in this field. Yeah, I don't have too much experience on this field. Yeah, but KSP encapsulated that, and KSP focus on the analytics stage only. So with KSP, you cannot touch the source code, yeah, but you can read them. You cannot write them. You can read them and generate some new codes. So my suggestion is to read out the KSP documents, yeah, and in their GitHub repository, you can find there's a simple directory, and yeah, you can get some inspiration from there.
So, and I would like to add that if you would like to start with writing compiler plugins, you need to start from the article writing your second compiler plugin. And on this series, you will find a bunch of interesting information. So can we use KSP to generate code in runtime that can be used by compiler? So it is about that question.
Can we use HTML code in runtime that can be used by compiler? I'm not sure what does this question mean. Can we in runtime? Yeah, because KSP running in compiling time, and then sorry, I really don't know how to answer this question.
I think that it means when you already done something and it is generated, it is compiled with all the sources, so it will be also used by the compiler. Perhaps you have already answered with the second question.
Oh, okay. Can be used to the compiler. Okay, yeah. So can refer to the my answer of the second question.
So, and maybe one more question.
Yeah, let's give it a moment.
So let's wait for several minutes. Perhaps maybe they will add something else. So, and what are you planning to do with your work about KSP? Maybe you will create some kind of production library, or it will be prepared in some open source. What do you plan to do with your KSP knowledge?
You were asking me, right?
Yes.
Oh, okay. So my next step, because I'm working on some KMM project, they call it multi-platform mobile. Yeah, so I would like to explore more with that concatenate library, in the multi-platform. And so in this case, I may need to improve something. For example, maybe there's something that only available or only accessible in JVM platform, in Android platform, but not available in other platforms. So I need to learn something new, improve that. So that's my recent plan.
Oh, that will be a really interesting journey, believe me.
Yeah. And because of the KSP, the KSP already supported I think almost all platforms, native JS. So I think my job will be easier, than I expected. Okay, here comes a new question.
Yes, does KSP provide interoperability between processors? Really important question.
I'm not sure how to answer this question yet, because from what I know, there's no other ways except basing on the source code and, for example, the annotations, to trigger between processors. So this interoperability, this is very hard question. So I can only describe the answer like this. So far. Okay.
So thank you.
Thank you.
Well, if there will be no question, we will finish up, or you just have several time to add something more. I know that a lot of people are interested in KSP, and perhaps they have a lot of things to ask our speaker.
So if there's no questions, I think that's all. But you can still like email me, or send some direct message to my Twitter account. Welcome to all questions. Thank you.
Thank you very much. We thank you for the really brilliant talk, and let's start our small break, and we will return here on 10:15 with another speaker. Thank you, Zhang. That was really awesome. And we are waiting for information and slides from you to share.
Okay. Thank you, Anna. Thank you, everyone. Bye.